the reports that came out, it's not economically feasible today. One of the aspects in not making it economically feasible is that they were utilizing large centrifuges to spin the algae down. When you're growing algae in these ponds, you're only getting about 0.1% of the system is algae. The rest, 99.9% or so, is water. You have to remove all of that water, okay, in order to get to the good stuff. That takes a lot of energy. Utilizing things like centrifuges are not the most efficient way to do that. So cutting down on the economics, on the inefficient processes that will make the economics more viable are part of it. Other areas that are critical in the sustainability are obviously land. Where are we going to do this? It's going to take a substantial amount of land to produce large amounts of fuel from algae.
But according to the one slide you put up, less land than corn.
That's correct. That's correct. So finding the right places to do that, whether it's in the Midwest, in areas that are not being used for food crop type growth, or that have the sustainable resources, or the Southwest where there may be a lot of land available, but maybe the water issue is a different problem, or the CO2 issue is a different problem. There are a number of components that need to be brought to bear in order to make it sustainable in the long run.
You're confident that those can be overcome?
That's why we're here, essentially. We want to make it successful. We want to make it successful for all of our partners and for our future. So yes, I am very confident that we can overcome these issues.
Question for you, Dick. You had up, I think it was your slide that showed employment, and the amount of employment that was associated with biofuels. To be really efficient, should there be ways to squeeze out jobs, or will more jobs reduce efficiency, i.e. increase costs?
Well, certainly there's a trade-off between the numbers of jobs that are required to grow the algae and whether you're going to be profitable. But that being said, an agricultural system that can be harvested every day means you have to have somebody working there every day of the year. And in the production, the harvesting, the extraction of the oil will require a number of people to manage those operations. And so we actually view that as a good thing, that we're potentially employing a lot of people. These will be both entry-level jobs as well as scientific positions and management positions that will have high salaries associated with them. So the full spectrum of jobs.
Do you see some of those jobs being filled by people moving from conventional fuel, because that may shrink, petroleum, coal, and so on, and some will be new jobs, brand new jobs?
Well, we think a large number of these jobs will actually be brand new jobs. It's a very different technology than extracting oil from the ground. So we'll engage farmers, we'll have engineers that'll be building these pond systems. There'll be agronomists, essentially, who will manage them. There are crop protection issues. If we have diseases in the pond, how do we control those? The same sort of technological issues that you would have associated with a large-scale farming operation. So that's a very different technology than extracting oil. Now, that being said, once the oil is extracted, the downstream technology is virtually identical. And so new technologies that have been developed just in the last 3 years to take vegetable oil or algal oil to produce gasoline, diesel, and aviation fuel have been developed. It's now possible to produce the full spectrum of transportation fuels using plant oils. So that technology is then strapped on the front end of the oil refinery, and then everything downstream is drop in. So the fuel will be the same fuel as we currently use, which means no change in the transportation of that fuel, no change in your car. to switch it to a different type of fuel. And we think that's a great advantage.
We use the same infrastructure,
Same infrastructure.
just a new
Yeah.
fuel source.
New fuel source, exactly.
I have a couple of other questions, but I think it's time to get the audience involved. There's a hand right there.
Yes, does algae use more or less fertilizer, particularly phosphate? And is that phosphate recyclable out of the process?
Well, so fertilizer is a major concern in the economics of producing algae, and you've really hit on one of the most expensive, of course, fertilizers, the other being reduced nitrogen. The expectation is that we'll be better at this than we were in the past with fertilizer use, and that we'll be able to recycle as much fertilizer as possible. There's also another approach, and that is to use municipal wastewater or water coming from feedlots that's very nutrient rich. And then it's really a win-win situation because we can use those nutrients to grow the algae and clean up the water that is eventually discharged from those sewage treatment plants. So we're going to try and conserve as much fertilizer as possible.
Yes.
I'd like to drill further on the economics so I understand it. I mean, ethanol has a government subsidy. Where do you have to get to really be competitive with gasoline default fuel line? I mean, are you off by 4x and you're going to do that with the NADS grant? So when does it really make a difference?
I'd like to piggyback on that. Phil, you mentioned a government subsidy for ethanol. Is it subsidy for corn-based ethanol or subsidy for any ethanol?
I believe that the current subsidies are mostly for corn-based ethanol.
Not
There
for
was-
algae-based?
There are no subsidies currently for algae-based. There was a subsidy up to, I believe, December of last year for biodiesel, but that subsidy has not been subsequently reconciled in Congress, so that's an issue for the biodiesel producers. The question is, where is it economically feasible from a production versus a subsidy standpoint? If we are producing fuel today at $10 a gallon, and we're seeing maybe $1 a gallon subsidy for both corn ethanol or biodiesel production, that doesn't reduce it by very much. We need to get another, as you stated, 2 to 3 times better efficiency in our economics in order to make that happen within the current market in the United States. I believe our targets, you're really trying to pinpoint me, Phil. Our targets are, I believe, $2 a gallon production of lipid and 40 cents conversion of that lipid into actual fuel. We believe if we can achieve that, then we have a commercially viable product. Okay? Can we achieve it within the 3 years of the stimulus funds? That is not really per se our target. Okay? It's our long-term target. We know that it may take longer to get to that viable economic picture. But that is it's a good goal to have. So I can't really tell you. I think you'd have to ask some of our commercial partners in order to pinpoint them more. I wouldn't want to talk for them.
But your economic viability is affected, at least somewhat, by the price of oil.
Very much so.
As the price of oil goes up, you can get away with less efficiency.
That's correct. That's correct. The market will bear a component there that's very critical. I agree.
Yes.